So in this video, we'll look at the function f of x equals x mod 5. So part A asks for the evaluation of f of 22. That simply means anywhere there's an x. Replace it with the number 22, giving you the problem 22 mod 5. Remember, to evaluate a mod problem, we do 22 divided by 5 in this case, which is 4. Not really what we're looking for. What we are looking for is the remainder. 4 times 5 is 20. 22 minus 20 is 2. That means the remainder is 2, giving f of 22 a value of 2. What is the domain of this function? Well, for the x's, we're going to be able to put in any value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, ... which means the set of whole numbers. So we will just say that x, that's it, x is an element of the whole numbers. For the range of this problem, that's the set of output values. The output value is the answers to each of these mod problems. So if we think about it now, we're taking whole numbers and we're dividing them by 5. The possible remainders then would be, if a number divides unevenly, it's going to be 0. A number like 6 or 11 or 21 or 101 for that matter would all have remainders of 1 when divided by 5. Numbers like 2, 7, 12, things like that would have remainders of 2 when divided by 5. And of course, you could have a remainder of 3 and a remainder of 4. You could not have a remainder of 5 because that means it would just be divisible by 5 and it would be to revert back to a remainder of 0. For example, 15 divided by 5 has a remainder of 0. So the range is always going to be the number written after the mod minus 1. It would be 0 up to that number. For what values of x does f of x equal 2? Well, I think we already mentioned a few of those values. Remember, f of x means the y values or the output. So when do we get output values of 2? Well, the answer is there's more than one answer. And they start with 2, 7, 12, 17, etc. We could represent this answer differently if we say, okay, well, we know that the output values would equal 2 when x would equal 2 plus 5 times k, where k is some whole number. In other words, some multiple of 5. So if we add multiples of 5 to the number 2, we'll get all values that are divisible, not necessarily divisible by 5, but give a remainder of 2 when divided by 5. What is the period of the function above? The period means how long does it take to repeat the pattern. In other words, how long does it take till we get the same output values? Well, I think it's pretty clear to see that the only output values are 0, 1, 2, 3, and 4. There's 5 different output values. So the next time you get an output value, let's say, for example, you did 6 mod 5, then 7 mod 5, 8 mod 5, 9 mod 5, 10 mod 5. When you did 11 mod 5, you'd be back to the same output value of 1. So the period is 5. It takes 5 numbers until you start repeating the pattern.